Here, this section is pretty easy. Angles of polygons, okay? So we're going to find and use the sum of the measures of the interior angles of a polygon. So we're going to go with the interior, and we're going to find and use the sum of the measures of the exterior angles of a polygon. Busy bees, busy bees. Okay, so here we go. Polygon interior angle sum. Okay, so a diagonal, guys. You all know a diagonal is like in a square, I guess, when you go from one corner to the other corner. A diagonal of a polygon is a segment that connects any two non-consecutive vertices. So these are vertices, you know, the corners. Now, if I want to connect this one to this one, that's not considered a diagonal. Since they're consecutive, no. We'd have to skip one. They're diagonal and diagonal. We can't connect this one here because that's consecutive or next to each other, so they won't be diagonals. So there it is. Cool. The vertices of polygon P, Q, R, S, T that are not consecutive with vertex P are going to be R and S. Therefore, polygon P, Q, R, S, T has two diagonals from vertex P, line segment PR and line segment PS. Notice that the diagonals form from PX separate the polygon into three triangles. So when you draw diagonals, they're basically going to form triangles. Pretty cool. Now, if I were to do it, I'm just going to say, if I were to do that from anywhere else, from Q, see, that's consecutive. So I go from here to here, and here to here. How many triangles can I form again? 3, right? Let me change it to one more color, and I'll pick right here. Look. Can't do that one. I can do this one here. And I can do this one here. So I'm going to get at, basically, you can only form what? The same amount, regardless. I can do from 3 from here, or 3 from here, or 3 from here. Regardless, you only do the same amount from each, I guess, vertex. Okay, the sum of the angle measures of a polygon is the sum of the angle measures of the triangles formed by drawing all possible diagonals from one vertex. So remember, a triangle had what? 180 degrees when you add them all up? So I would have two triangles, well then I'd have 180 here and another 180 here. So the angles would all sum up to, well, you can think about that, two 180s, right? Now if I were to have this figure here and I could form, well, like this one, right? I could form that many triangles, and I'd have 180 degrees here, 180 degrees here, and 180 degrees here. Now this right here, I could form that diagonal, that diagonal, that diagonal, 180, 180, 180, 180. Pretty cool. So remember, the sum of the angle measures of a polygon is the sum of the angle measures of the triangles formed. So we add up all these triangles, that's how many degrees are in this, whatever shape this is. Whatever the shape this is, however many triangles you can form is the degrees of the interior. So in a triangle, you could only form one triangle. In a quadrilateral, you can form two triangles. Slash, you could have 180. Pentagon, 180, 180, and 180. I don't know what that is anymore. Amount 540. And then we're going to come out here. Since the sum of the angle measures of a triangle is 180, we can make a table and look for a pattern to find the sum of the angle measures for any convex polygon. So we use this for convex polygons, guys. Do you remember what convex was? Convex meant when you extended the sides, the line did not go to the interior. It does not go into the interior. Okay, remember, this is convex because the lines, when you extended the side length, or say a line that contains the side length, it does not go to the interior. So this happens with convex. So a triangle, 3 sides. There's a total formation of 1 triangle, total degrees 180. Quadrilateral, 4 sides. You can form 2 triangles, 2 times 180, 360. Pentagon, 5 sides. You can form 3 triangles, slash 3 times 180, 540. Hexagon, 6 sides. You can form 4 triangles. So here's a pattern. Hopefully you picked it up. Whatever number side you got, whatever it is, you can always form 2 less number of triangles. So if I have 6, 2 less of that would be I could form 4 triangles. If I had 5 sides, I could form 3 triangles. If I had n-sided and n-gon, then I could form n minus 2. And the total degrees would be n minus 2 times 180. Only for convex. We're going to go with only convex. This leads to the following theorem. Polygon interior angle sum. This is a pretty cool idea. I like this idea, really cool. So the sum of the interior angle measures of an n-sided convex polygon is the quantity of n minus 2, remember n is going to be the number of sides, times 180. So in this situation, I had 1, 2, 3, 4, 5, what? A 5-sided thing? I don't know what that is. 1, 2, 3, 4. Pentagon, right? Yeah, pentagon. 5 minus 2 gives me 3 times 180, 540 degrees in all this math. Do me a favor, copy this down real quick. Okay, so recall, guys, that in beginning of the year, 1/6, we learned that a regular polygon was a polygon. Oh, wait, I went too far. Here we go. You can use the polygon interior sum theorem to find the sum of the interior angles of a polygon and to find missing measures in polygon. So if you look at this real quick, we're going to come out here and jump into it. Find the sum of the measures of the interior angles of a convex heptagon. Now on the side over here, here are some common ones that we use. 3 sides triangle, quadrilateral, pentagon, hexagon, heptagon, octagon, nonagon, decagon. I don't even know what that is. I think that one's talking bad about my mom. I don't even know. Or that anagon. I always go anagon. I don't know why I like it. It's just anagon. Forgive me. Okay, so here we're gonna and the examples we're gonna use today, they refer back to this. Okay. So in case you're wondering what these are, and there they are. Okay, so find the sum of measures of the interior angles of a convex heptagon. Heptagon, I think, is 7 sides. So basically, we're going to come out here and use that same formula they gave us. You're going to use the interior polygon, interior angle sum theorem, and we're going to have n, which is the number of sides. So we're going to replace that n with a 7. 7 minus 2 is going to be 5. 5 times 180, or 900 degrees. So now all the angles would add up to 900 degrees for a heptagon, a convex heptagon. Forgive me now. Okay, now we're going to find the measure of each interior angle of a quadrilateral ABCD. So here are my angles. I know what these two are. I don't know what these are. But I can go ahead and tell you the total sum. Since this is a 4-sided figure, I'd use the formula. 4 minus 2 is equal to 2, right? 2 times 180 is 360. So in all, this is 360. I don't know how you want to do this. This is really easy. You can say, well, this is already 180, right? So you can say these are equal to 180. The way the book does it, it says, well, the whole thing, all the angles added up together are equal to 360, which is true. Okay, so then we kind of, I'll just show you the way they did it. I would have gotten rid of these and said it's equal to 180. See, I would have started here. But they're saying 360 is equal to the 4 angles, 3x plus 90 plus 90 plus x. Slash gives you 4x plus 180. Subtract that 180, so it gives you 180 is equal to 4x divided by 4. So now x is equal to 45. So now in this situation, you know that's 90, 90. This one's 45, and this one's 3 times 45. I think 155. I don't know what it is. 135. And there it is. Not too bad. I like this one. I think that's pretty cool. Going once, going twice. Okay, let's go and try this one right here. Make sure you know this thing is a 1, 2, 3, 4, 5, a 5-sided thing. Okay, so we're going to go right here. 1A, find the sum of the measures of the interior angles of a convex octagon. Next one we'll do is 1B. Find the measures of each interior angle of the pentagon HJKLM shown here. So I'll give you a couple of minutes to copy it down and to work on number 1A. Okay, make sure you write the directions down, guys, and make sure you drew this pentagon. Okay, so we're going to go to number 1A. We're going to go and find the sum of the measures of the interior angles of a convex octagon. Sorry. So remember the octagon, when I hear octagon, I think of what? The MMA. Crazy, right? 8 sides. And so when it comes to that one, the formula for the polygon interior angle sum theorem. So the angle sum theorem basically says if you have n minus 2 times 180, right? In this situation, this is going to be my n. So I'm going to go with 8 minus 2 times 180. This gives me what? 6 times 180. And if you do the work, I think it gives you 1,080. 1,080 degrees inside the the sum of the interior angles. Not too bad, right? Pretty easy. Okay, 1B it, ready? 1B it. Let's get 1B. So when it comes to 1B, it's going to say refer to this side right here. Now regarding this one right here, we can kind of look at this thing and say, well, what do I know about this? Well, I know it has 1, 2, 3, 4, 5 sides. So what I want to do is, I want to approach it like this. I want to find out what everything is equal to. Set it equal to what it's equal to. Solve for my x, and then come back here and plug them in. I think that's the only way to do it. So in this situation, I'm going to have the formula again for the polygon interior angle sum theorem. It's going to be equal to n minus 2 times 180. So I'm going to go in this situation, there's what, 5 sides? So it's pentagon, which I'll go and say n, right, is equal to 5. So we're going to go with here and say 5 minus 2 times that 180 using that formula. So we're going to come out here and go with 3 times 180. What was that earlier? You know what it was? 540? Let me just come out here and double check. 0, that is 24. Okay, so 540 is equal to all these angles together. Oh, great. This is going to be a tough one, I guess. That's not that bad. Here you go, ready? So we're going to go with 540 is equal to, I'm going to start here, h, and go around this way. All the angles together. Every single angle added up together, you know, at least the degree they gave us here, will equal that 540. So we're going to add them all up. 2x, and then we're going to add up the 142. My pen's ready. Plus 2x, plus 3x, plus 14. Plus another 3x plus 14. Okay, let me just see. 1, 2, 3, 4, 5 angles. 1, 2, 3, 5 angles added up. Perfect. So now we're just going to have to clean it up. It's easier than what I thought. So let's come out here. How many x's do I have? 2, 4, 7, 10. That's not too bad. That's going to be an easy number to divide by. Plus all the numbers here. Okay, 142. Okay, this gives me 28. So 142 plus 28. 6, 7. What do y'all think? Okay. No more numbers, no more variables. Let's double check. 4, 7, 10. Yeah, looks good. So we're going to minus 170. And then we're going to borrow here. 0 becomes a 4, 7 equals to 10x. Now this, I'll divide by 10. Divide by 10. X is equal to 37. We're okay with that one? What do y'all think? Just double check my math. I think it looks good. 10x, 142. This is 28. 8, 0, 20, 60. Yeah, 70. Perfect. Subtract that one. Can't be 4. Yeah, it looks good. Divide. At least everything's pretty good. So let's come out here and find the angles, okay? So angle, I guess I have room over here. Oh yeah, I can just move it up. We have to name each one. Angle H, which is equal to what? 2 times 37? Which is, what is that? 74? Angle J. Well, we already know that one. 142. Angle K. We already know that one actually, right? 2 times 37 again, which is 74. Angle L is going to be 3 times 37 plus 14, which is, I'm going to step on the side over here. 37 times 3, 21, 9, 10, 11. 21, 9, 10, 11, and then add 14 to it. Gives me a 5 to 125. And thank God it's the same numbers, right? Angle M, I'm just going to say 125. And let's just put ditto. What do y'all think about that one? Not too bad? I think that was too bad. Going once, going twice. Okay, so remember this one, guys. All the angles were given to us kind of in a weird X idea. I put them equal to what the total, angle sum was. So interior angle sum turned out to be 540. I used that one by getting the n, which is the number of sides. It was 5. Subtracted 2. Use the formula they gave you. N minus 2. 5 minus 2 gives me 3. 3 times 180. 540. 540 is equal to all the angles together. Added them all up. Solved for x. I figured out what my x was. Now I just simply went back to each angle individually and plugged in the x value and found out the degrees. Okay, so recall from the lessons, guys, the first 6 weeks, the regular polygon. Regular polygon meant that what was congruent. Do you remember what the regular polygon meant? All angles were congruent and all sides were congruent. But since we're just talking about the angles, we're going to talk about the interior angles today, and that all the angles are congruent. Okay? So if it says regular, they're equal. They're all the same. Okay, so the tent poles for a tent from the vertices of a regular hexagon. When the poles are the poles for a tent form the vertices for a regular hexagon. So I'm going back. Regular means all the angles. You see this angle, basically this is like a top view. All these angles here are the same. They're not showing it here, but all these side lengths are the same. When the poles are positioned, are properly positioned, what is the measure of the angle formed at the corner of the tent? So basically, what's this angle here? Well, regarding this one, I can figure out the angles of each one. How? Well, if I know that it's a regular one, then I know I have whatever interior angle sum and divide it evenly, if that makes sense. Okay, so a hexagon. Do you remember what a hexagon has? How many sides a hexagon has? It should have 6. So we're going to come out here and find the interior angle sum. So we're going to find the interior angle sum by saying there's n sides / 6 sides minus 2 gives me 4 times 180, which is now equal to 720. Now, that's 720, all of them added together, the interior angle sum, right? Now, if it's a regular polygon, there's how many angles? 1, 2, 3, 4, 5, 6 angles. So I get that 720 divided by 6. Now that shows me that when I have a regular polygon, all angles are congruent, that each angle is a 120 degrees. Pretty cool. Not too bad. Okay, let's try one on our own. Let me go to the chat, guys. Anybody in the chat need help? Anybody, did I lose anybody anywhere? How do you feel? Okay? Checking out the chat. Look good? All right, game on. Okay. Coins. Find the measure of each interior angle of the regular, whatever that is, Heptagon, that appears on the face of a Susan B. Anthony $1 coin. Okay, where is it? Is it 11? Okay. Yeah, looking at the book here, it's an 11 site. So let's come out here, guys. Copy this one down. This is 11 sites. Non-agon, I think it's a 9 sites. For the next one. Okay, let's try this out real quick. I need some magic. Anybody have a calculator? Anybody ready with a calculator? Okay, so we're going to find the measure of each interior angle of a regular, which means equal, okay? Equal sides, equal angles, of a Heptagon that appears on the face of a Susan B. Anthony $1 coin. So regarding this one, we're going to come out here and say, well, in n, remember the formula, n minus 2 times 180. We're going to come out here and basically, the Heptagon means 11 sides, so we're going to substitute the 11 in here for that n. Let me give you n now is going to be 11 minus 2, 9 times 180. Anybody do that one already? Anybody do? 9 times 180 anywhere? Great. Here we go. 180 times 9. 1620. Okay, so all the sides together, all the interior angles together give me 1620. Now in that situation, it's going to be, Heptagon means all angles. So there's 11 sides, we're going to have 11 angles. We're going to divide it by there. I am just going to use a calculator for that one, if you don't mind. And then it's not ready. 9 times 180. I hope I did the math right. Okay, nobody? Anybody? I'm still doing it on the calculator. I did it on my phone calculator, and it gave me 1 147. And then you convert that, it's going to give you 3/11. Yeah, 3 left over. Okay. Going once, going twice, not too bad. So each angle from the Heptagon is going to be 147 and 3/11 degrees. Okay, a certain company makes hot tubs in a variety of different shapes. Find the measure of each interior angle of the regular non-Octagon model. Okay, so we're going to find the interior angle, right? We're going to find each interior angle. So it's the same approach, I think. So we're going to go ahead and regular formula. N minus 2 times 180. So we're going to go with 9 minus 2 times 180, which gives me 7 times 180. 180 times 7, 0.56. Whoa, what is that? 12. So now we have the total sum. 1260. We're going to divide it by how many sides? By 9. Come on, calculator. And then each interior angle is going to be worth 140 degrees. Going once, going twice. How do y'all feel about that one?